TCP segment format. Okay, so as we have already discussed in the last class, so segment is nothing but the header plus my payload or data. This is my header plus my application layer data, or more technically we call it the payload. And in the last class we talked about, as far as the header of TCP is concerned, it varies from 20 to 60 bytes. Okay, 60 bytes. Whereas the segment or header length of UDP is concerned, it is only 8 bytes, that is fixed. So but TCP header length is not fixed, it is minimum 20 and maximum 60. Let's look into that, what is there in the minimum 20 bytes to 60 bytes as far as TCP is concerned. Okay. So the first, so every row, as I have already told, it is 32 bits. So 0 to 31. Okay. So then the first one, first row, second row, just I am putting the rows. Third row, fourth row, and fifth. Let's have like this. I will tell what is the significance of it. So this is 16 in the hub. So first one is source port, as it is in UDP, that is represented in 16 bits. Then the destination port, it is also represented in 16 bits. Then next important point is here sequence number. We'll talk about it, very, very important, sequence number. That is in 32 bits. Okay, the whole row is occupied by the sequence number, that is 32 bits. So then the acknowledgement number. N-O-W-L-E-D-G-M-E-N-T. Acknowledgement number. That is again in 32 bits. Okay, the next row is very, very important as far as our, so I mean TCP is concerned. So if I go and have, so this part is window size 16 bit, and the rest part of it is 6 flags. So header length, this is H length, header length represented in 4 bits. Okay, so whatever bracket I am writing, that is the number of bits occupied to represent that information. Very, very important. Let's try to understood. So there is some flags, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. There are 6 flags. Okay, so and the rest part is reserved. This is reserved. This is 6 bits reserved. Okay, 4 plus 6, 10, and this is another 6 bits, 16. So what is this? So the first flag is called as URG. We'll talk about in detail. So right now, so the next flag is ACK. Next flag is PSH. Next flag is RST. Next flag is SIL. Next flag is PIN. Okay, these are the flags we'll talk about in detail. Okay, there is one more row I have left out actually. Sorry. So this is
for checksum.
Yeah. So there is one more. Sorry. So this row actually basically again contains 2 important information. So one is called urgent pointer. 16 bits, and checksum 16 bits. And so if I look into this, how many rows? 1, 2, 3, 4, 5. 5 rows means each row is 4 bytes. So 5 into 4, 20 bytes. So this remember this 5 rows is mandatory, because 20 byte is the minimum length of the TCP. These 5 rows is mandatory. After that, so depending on the requirement, so another 40 bytes of information can be added as a option field. So this is optional, options and padding. We call it the options and padding field. Okay, and that is so 40 bytes. Okay, that is 40 bytes. Okay, so let's go and look into in detail. So the significance of each and every field in this TCP. So we have already talked about source port and destination port. So in case of UDP, that remains the same. Oh, we don't have to so much look into this. Same thing. So that is source port and destination port. So usability in TCP as well. Now coming to the next point. So that is a sequence number. What this sequence number and acknowledgement number is. So there. Let's try to understand. Let me so tell. So whenever there is a communication going on, so between the TCP client and TCP server, let's say this is my TCP client. This is my TCP server. Whenever I want to communicate between a TCP client and server, okay, let's say I send some data to the client. Sorry, I send some data from the client to the server. Then what the server is going to do, server is always going to send an acknowledgement on behalf of the data received. So this is the rule as far as TCP is concerned, because TCP is reliable. So if I want to say reliable means I should know whether my data is received at the other end or not. So if I'm sending some data as a client, if I'm sending some data to the server, then I should know whether my data is received or not. How do I know? Then server should send some acknowledgement, that is your data is received. So whenever you send some data, always the recipient is going to send back say acknowledgement saying that what data you have received. So from that you could able to know whatever data you have sent, whether you have received, whether your receiver is received that data or not. So that's why, so in order to achieve this, while sending data, so client or the sender is associated the data with a sequence number. Okay, in order to know, because I have to know so which data is received. Maybe let's say I have sent 1000 bytes of data. Let's say for example, I have sent 1000 bytes of data. Whenever I send 1000 bytes of data, as TCP is stream oriented, not packet oriented, so it might happen, so it is going to go as 500 bytes, or it may go as 200 bytes करके 5 पैकेट जा सकता है. So it depends. So that's why, so whenever I'm sending, okay, let's say first 500 bytes is received, but the second 500 bytes is not yet received. So I should know so which so sequence, that is, if I look into this, so I have to know which part of my data has been received, which part of my data has not been received. So for that sake, every data will be associated with a sequence number to know which part of the data is actually received at the recipient end. Similarly, so whenever it is going to send back me the ACK, it is going to tell a acknowledgement number or ACK number to let me know what part of the data is received. So in sequence number, I am saying what part of the data I am sending. I'm sending 1000 bytes of data, let's say. Okay, so with a sequence number, I will tell in detail with an example so that you can understand very clearly. Okay, so overall you try to understand whenever the sender is sending, so it is going to associate the packet with a sequence number to inform the sender, is the receiver, what packet I have sent. But so whenever the receiver is going to send a ACK, he is going to tell me what part of the packet he has received. So that's why sequence number is going to tell me what part of the packet is sent. Acknowledgement number is going to tell me what part of the packet is received. So that's why this sequence number field and acknowledgement number field is going to help me to achieve reliability, to know what are the packets or what are the bytes so that is being sent and received properly, and that is required as far as reliability is concerned. So that's why sequence number and acknowledgement number are very, very important. Now one more important thing, try to understood. So let's say, so what the sequence number tell. So whenever I'm sending a packet, so try to understood. So whenever I'm sending a packet with a sequence number, okay, sequence number is, so let me give the example so that I can understood better. So in that sense, I can make you explain how the sequence number and acknowledgement number are related to each other. Okay, so now go through an example beyond it. 120. Okay, so let's say this is my sender, this is my receiver, this is my receiver. Okay, now let's say sender is sending a packet with a sequence number of 20 with an acknowledgement number of, let's say, 857, and the data, I'm sending a data of, let's say, 1000 bytes. Okay, so now let's say the sender is sending a sequence number with 20, acknowledgement number with 857, data of 1000 bytes. Now, as a part of it, the receiver is sending a ACK, okay, with a sequence number, with a acknowledgement number, and let's say the data sent by the receiver is, let's say, so 100 bytes. 100 bytes of data is being sent. Now we have to think of what should be the value of a sequence number, what should be the value of ACK number, so as to understood each other what has been sent and what has been received. That is what is required as far as reliability is concerned. What the other end is expecting, so other that is only going to be so understood from the acknowledgement number. That means acknowledgement number tells what I am expecting. Initially, it will be a bit confused, but once I give the example, it will be clear. Okay. So now, what the acknowledgement number is saying, let's say the sender is sending a ACK of 1857. What is the meaning of it? That is, I am expecting a packet next time from the receiver with a sequence number 857. That means I am expecting a packet with a sequence number of 857. So from the receiver next. Why? Why? Because I have already received packet with sequence number 856. I have already received. So packet up to sequence number 856. That's why I'm expecting a packet with a sequence number 857. Are you getting my point? What ACK is saying? ACK is saying, acknowledgement is saying what I have already received and what I am expecting next from the other end. I was discussing ACK number. If ACK is 857, what is the meaning of it? The meaning is that the sender has already received packet up to sequence number 856. What is the meaning of it? ACK is 857 from sender means, so he has already received packet up to 856, and what next he is expecting from the other end? 857. Okay, are you getting my point? So if
21.
Yes, so he has sent a packet whose starting sequence number is 20 and it has sent 1000 bytes of data. Okay, one more concept you need to understood. So to understood this. Okay, so I have to send a packet now. Now the sender has sent a packet with a starting sequence number of 20 and he has sent 1000 bytes of data. Remember one concept. So every byte, every byte in a packet is associated with a sequence number. Every byte in a packet is associated with a sequence number. If there are 1000 bytes, so the sender has sent, how many sequence number is associated with this particular packet? 1000 sequence number. 1000 sequence number. Every byte has to be associated with a sequence number. Can anybody tell me, sir, why should I go and attach sequence number to every byte? What guarantee? It might be divided into 5 packets. It might be divided into 10 packets. It might be combined with another data and go and send. So I cannot provide one sequence number to one packet. So that's why as TCP is stream oriented or byte oriented, that's why remember every byte of the TCP is associated with a sequence number. Very, very important point we have to understand. If that is the case, if the first for the sender has received this, sender is now going to send back some data to the other end. So let's try to understood what should the sequence number of the data he is going to send, what should be the acknowledgement number of the data he is going to send, and let's say the sender is sending data of 500 bytes. Based on this, that's why the sequence number of the packet I should go and send to the other end is 1020, because always remember what ACK I have received. So based on that, I have to populate the sequence number of the next packet. Just in very simple term, जो पैकेट मैं रिसीव किया हूं latest, so उसका ACK क्या है? What is the ACK I have received? That should be my sequence number in the next. Receive a packet of 100 bytes, And what is the starting sequence number of the packet I have received? 857. What is the ending sequence number of the packet I have received? Sorry, 956. Okay, if the starting sequence number of the packet I have received is 857 and it is of 100 bytes, what is the last sequence number of the packet I have received? 956. If I have received up to 956, what am I expecting next? 957. That should be my arc. So my arc. So whatever is the actual value is 60. But as far as my S length field is 60, so concerned, I can store up to 15. So how to make it? So if I go and divide 60 by 4, then I got 15, na? Yes or no? If I divide the 60 by 4, so I got a value of 15. So that's why remember this concept. Whatever is the actual header length, it has to be divided by 4 to get the header length that is to be stored inside this H length field. That means if the actual header length is 60, then I have to store so 15 in the header length field. Similarly, so actual header length, so the H length field value which is going to be populated in the TCP header is going to vary from 5 to 15. Okay, and always remember that the header length should be always in multiple of 4. It cannot be, it has to be either 20, then it has to be 24, then it has to be 28. It cannot be 21, 22. Okay, so this is the reason. So the header length always is a multiple of 4, and that's why every row is represented as 4 bytes. Basically, that is the reason why you are representing every rows so in a particular header format in 4 bytes, because so these flags are very important. We have to come later for these flags. Okay, there are 2 categories of flags, so we'll talk about. So now coming to the window size. What window size is? Window size is basically used for ensuring flow control. We have already talked about flow control. So in flow control, what I talked about? I talked about so the sender has to control its flow, or sender has to send the data as per the capability of the receiver. But so how the sender is going to know what is the capability of the receiver? So that's why always the receiver is going to advertise its window size in the window size field, so that sender can go and know what is the receiver capability, and so based on that he can go and manage the flow. So that is, he can apply flow control. So that's why window size is going to help us to achieve flow control as far as TCP is concerned, to achieve reliability. So how exactly it is going to do, we'll talk in the next classes. Okay, but you understood only what is the significance of it. Window size is basically used to apply flow control or achieve flow control, so as far as TCP reliability feature is concerned. Okay, now coming back to checksum. Already we discussed checksum in UDP. The same concept applies to checksum as far as UDP is concerned. We don't have to bother about it. So now, coming to this urgent pointer, I will talk about once I talked about this. Flags. Let's coming to the flags. Okay. So I talked about there are 6 flags. Each flag is 1 bit. So PIN, SYN, and RST. These 3 category of flag is basically used for connection management. Connection management. What I mean to say by connection management: creating a connection, tear downing a connection. So all these things has to be managed by these flags, using these flags PIN, SYN, RST, which we are going to discuss in the next classes to happen. So how a connection can be established, how a connection can be tear down, how a connection can be reset. So these flags we'll discuss in detail. But in today's class, let me talk about these 3 flags: URG, ARC, and PSH. Let me go and talk about these 3 flags: URG, ARC, and PSH. ARC is ARC is basically nothing much to talk about ARC. Let me talk about ARC. So what is the ARC? So that means whenever you are sending a data, so the other end is going to send an acknowledgement. So if it is an acknowledgement, so then ARC field should be set. If it is only data, if I'm sending only data, there is no acknowledgement, so ARC field is not going to set. ARC field is set to inform the other end. So I'm sending an acknowledgement on behalf of the data you have sent to me. So that is the use of acknowledgement field. Okay, but so let's try to understand this importance of URG and PSH. Very important, URG and PSH. Let's look into that. Okay, so URG and PSH. URG and PSH. These 2 flags is very important. So PSS flag, let's look into PSS flag. PSS flag is called as push flag. What is a push flag? So what I have already told, so when a sender is sending data, when a sender is sending data to the receiver, let's say sender is sending so 1000 bytes of data. So in the first packet he has sent 1000 bytes of data. In the second packet he has sent 500 bytes of data. In the third packet he has sent 200 bytes of data. There is no guarantee, I have already told. So whenever the sender is sending data so to the receiver, so the data is going to immediately send. Agar maine 1000 bytes of data I am sending, it may not happen 1000 byte of data is immediately going to send to the other end. Rather it might happen. So it is going to combine all the three bytes of data, so and make a 1700 bytes of data to send to the other end in one packet. Okay. So what I'm saying, that means data is not going to be sent. There is no guarantee whenever you are sending the data is going to send immediately to the other end. It may have to wait. So in the buffer, so there is a buffer maintained at the sender end. Okay. So unless until that buffer is filled, so data is not going to send. If the buffer size is, let's say, so 1500, let's say for example, if I'm sending 1000 bytes of data, now it is go and come and sit in the buffer. Then another 500 bytes of data. Now the buffer is full. Now the data is sent. Try to understand this concept. That is, sender is not going to send the data. So even if the sender is sending a data, there is no guarantee that the sender data is going to send immediately to the receiver. Rather, it is going to wait till the buffer is going to full. And once the buffer is going to full, the whole buffer is going to send to the other end. That's why TCP is called as byte oriented, not packet oriented. Okay, but what is the problem if it is going to happen? So let me talk about an example. Let's say you are chatting with your friend. You are writing hello, hi, how are you? So if you are sending hello, how are you? Do you want your, so whenever you are writing hello, hello has to receive, or you want hello, how are you, I'm fine, everything will be combined and will be received at a later point of time to the other end. Which one you better? Think better as far as the chatting is concerned. Which one is better? Hi likhe, hi pahunch gaya. Ho likhe hi, then you go and tell how are you. So is it better, or you are going to write multiple so messages, and multiple messages are going to combine as far as TCP is concerned. So that is going to send to the other end. That is better. Which one is better?
Sir, first one.
So first one, that is, so immediately whenever you are typing something, that should go. So whenever you are sending 1000 bytes, it should not wait. It has to go immediately. If that is happening, so as far as chatting is concerned, so that is going to helpful for me. Otherwise, it is not very much so interactive for me. I do not like that chatting so application. So that's why in order to support this PSS flag is there. That means whenever PSS flag is set, what the sender is doing, whenever sender is sending 1000 bytes, it is not going to wait till the buffer is going to full. Rather, it is going to send the data immediately to the other end. So thereby making a chatting type of communication. That is also required at certain point of times. At certain point of times, by using TCP, I do not have to wait for fill up the buffer. Rather, I want to send the data immediately to the other end. And at the receiver end, also I want to receive it immediately. So that's why in this kind of scenario, this PSS flag will going to help me to carry out this type of operation. That is where PSS flag comes into picture to help me to do my communication or chatting very interactively. That's the use of PSS flag. Let's look into URG flag. Okay, URG flag stands for urgent. It's an urgent flag. What does it mean, urgent? Let me give an example. So let's say you are sending a very huge file. Let's say you are sending a file of, let's say, 100 MB. Okay, you are sending a file of 100 MB to your friend, or maybe let's say 500 MB to your friend. You are sending a file whose size is 500 MB to your friend, but suddenly you feel that after clicking the send button, okay, कोई भी application आप use करें send करने के लिए, उसका send button आप दबा चुके हैं. You have already click on the send button. Okay, but you immediately find after clicking the send button, अरे मैं गलत फाइल भेज दिया. आप send so wrong file. It's not the right file. So right file is not sent, rather a wrong file is sent. Immediately you want to avert it, avert that sending operation. So in that case, you have already sent this. This data has already go ahead. So now what you want? You want to avert this operation. Okay, that means this data has already traveled in the network, and now after that you are sending a abort so control information to abort this information. So this abort information should go ahead of this data so that it can go on so abort this data sending. Otherwise, if this abort information is going to follow this data, so this data is never going to be aborted, rather this data is going to receive at the recipient end, so 100%ly, which is unnecessarily utilization of the bandwidth, so poor utilization of the bandwidth. So that's why, so in that case, this abort operation should be go on top of this data. So that's why I have to say that this is urgent data for me. This abort is a urgent data for me. Please process this data ahead of any data you are so communicating at this point of time. In that case, so the urgent flag should be set. Whenever there is some data which is to be processed ahead of any data, so in that case, so this URG so flag is going to be set so that it is going to so do the processing faster at any end. At any end, whenever some urgent data is received, some non-urgent data is received, first of all the urgent data is going to process on top of the non-urgent data. So that's why it is going to help me to so possible to abort the data communication at some point of time instead of completing the data communication. So that is in the scenario so where URG flag is going to help me to carry out this operation. But so whenever urgent data is going to combine with non-urgent data. So let's say for example, so there are 1000 bytes of data is going. So the first 100 bytes of data is urgent. So next 900 bytes of data is non-urgent data. That means urgent data can be combined with non-urgent data. So while traveling in the network. So when 100 bytes of data is urgent, I have to know na. So URG flag set करने से मुझे पता चलेगा it's a urgent data. Okay, but how much data out of the whole data segment so is urgent, that I have to know na. So that's why so the urgent so pointer is there. If you look into here, there is an urgent pointer na. Urgent pointer is going to tell me how much amount of data is urgent so out of the whole data that is being carried out at this point of time. That means in this example, if I look into this example, so here urgent pointer should set with a value of 100. Okay, that means if the urgent pointer is so when URG flag is set, at that point of time only urgent pointer is going to populate. And what is the significance of this urgent pointer? Urgent pointer tells how much byte of data is urgent out of the whole segment that is transmitted. That means so if 100 bytes, first 100 bytes of data is urgent, in that case urgent pointer will be set to 100, telling first 100 bytes of data is urgent for me, so that this first 100 bytes of data is processed at the receiver and at any point of time, so on top of any other data, so thereby achieving the